What's up, everybody? It's me, CJ, your favorite math mentor, teacher, tutor, whatever you want to call me. And today we're going to be talking about a topic that a lot of people have been struggling on lately, and that's instantaneous rates of change. Now, I understand the struggle. I was once in the same seat as you, doing the same lesson, and it's hard, all right? But, I pushed through, did my homework, studied every day, and now I'm at a point where I can teach you, all right? So, if you feel a little bit discouraged, don't worry. Just keep going at it, and you'll get it eventually. Just like most things in life, you can learn a lot about your life in math. All right, all right. But anyways, let's get into it. One thing's very important is you to take notes during this lesson. All right, just take notes, or maybe if it's right before a test, you don't need to take notes. Just kind of listen to everything I say. But before you take notes, I'm gonna give you a little bit of kind of understanding the concept of the instantaneous rate of change that we're going to be talking about today, because to really be able to do it, you kind of got to understand it. So you don't need to take notes of this, just kind of grasp it in your brain. All right, so there's a thing in calculus, we haven't gone over it yet, but it's called a derivative. Now that sounds like a scary name at first, but it's not that scary. So here's an example. This is a function f of x, just like a random scribble, and then here is f prime of x, which is the derivative of f of x. And you don't need to know any of this at all, but there's a few scary terms in there, but all you got to really look at is what it means. So any point on the f of x graph, let's say we pick this point at 2, this is like 2, like -1, right? And we're going to look at the slope at that point. So let's say the slope looks like around -1, right? We can even draw a little tangent line in there. Like that slope looks like it's about -1, right? We'll say that's -1. So if we go to our f prime of x graph, our derivative of f of x, we'll see at the same point at 2, our point is at -1. So basically all the points on the derivative graph, or the f prime of x graph, are the y values are what the slope is on the f of x graph. So here, like, the slope is 1. Come down here, the slope's around 1. So yeah, that's basically the gist of it. So basically what we're doing when we're kind of deriving the instantaneous rate of change is we're finding the derivative. We're finding a function that can represent all of the values, where you can find just the slope at any point of the original function, if that makes sense. So moving on, average rate of change. We all know how to find average rate of change, right? y2 minus y1 over x2 minus x1. Take any 2 points in the graph. Looks something like this. Let's say you have those 2 points, that line through it. That's the average rate of change through those 2 points, also known as a secant line. That might be an important vocabulary for you. But we don't want average rate of change. We want the instantaneous rate of change. So the first thought that comes to mind, like, what if we just take the same point and plug it into the average rate of change function twice? Well, if you do that, you end up... Oh my god, there's stuff in the way. All right. If you do that, if you plug the same point into the average rate of change function, you're going to get 0 over 0. And guess what? You can't do that. That's impossible. There's an x there. So you have to do this instead. You're going to add a little h into the thing. This is the same as the average rate of change function, but the y is now f of x, and it's going to be f of x plus h, and x plus h. So basically, think of it as you're trying to find the average rate of change between x and f of x, and x plus h, and f of x plus h. And then that can be with numbers too, as I'm going to get to into a second. But basically you're plugging it in like that. And the reason we put an h is because since we can't just put it in straight up, because we'll get 0 out of 0, we kind of got to put a little thingamajig in there so it doesn't end up at 0 and 0, and we can get an actual answer. H represents the distance between the 2 points, and why it's approaching 0 is because as that distance approaches 0, it'll get closer and closer to just being one value. And then, so by putting limit of h approaches 0. It's basically saying like just that one value. And as you can see, as it's approaching 0, we'll see this point here on the left is getting closer, closer, and then all of a sudden it turns into 1 point, which is our instantaneous rate of change, or our tangent line, which is just the line that touches 1 point and then follows the same slope. So yeah, you can see it gets closer and closer, and that's why we put the limit of h approaches 0, because the points get closer and closer to having 0 distance in between them. So the only thing you really need to write down is maybe this little equation right here, f of x plus h minus f of x over x plus h minus x. And yeah, let's move on to our first problem. So there's really two ways you can go about finding an instantaneous rate of change. You can find it using the number, or you can find the equation that shows all the numbers and then just put a number in there. It's probably better that you just know both ways, because on a test you're probably going to need to show that you know both ways. So this is how you do it with numbers. So we got our function f of x, or should be f of t, but we'll just change it to x. We'll say f of x is equal to negative x squared plus 4x. All right. We want to find the instantaneous rate of change at 3. All right. So let's look at our thing again. So we got x of f of x, x plus h, and f of x plus h. Like I said earlier, we're just basically trying to find the average rate of change between these 2 points. But since we're doing it with a number, we're going to have to plug it in a little bit. So x in this case is 3. So 3. Now we got to find what f of 3 is. So let's do that real quick. F of 3 is equal to negative 3 squared plus 4 times 3. So that's negative 9 plus 12, which is equal to 3, right? So I think that's it. So it's at 3, 3, and then we got 3 plus h times negative 3 plus h plus 4. All right, this is kind of getting in the way a bit. We'll just draw a line here. 4 times 3 plus h. So you see what I did there? So that's just x plus h. And then since for this one, we can't really simplify it because the h is in there. We just kind of got to write out the whole function, but with 3 plus h as x. So yeah, replace 3 plus h with x here, and then that should be your y value for this one. So now we're just going to plug it in to our average rate of change, which is now our instantaneous rate of change since we're using the plus h. So we're going to take a look down here if we want to check it out again. Should be f of x plus h minus f of x over x plus h minus x. And then we can add the limit of h approaches 0, but we don't have to until the very end. So let's see. All right, here we go. Okay, so we got, this is a little bit of the tedious part. Got 3, negative 3 plus h squared. Forgot to add a squared here. Plus 4 times 3 plus h. There we go. And then minus our f of x, which in this case is just 3, over 3 plus h minus 3. Now here's a little tip. Whenever you have this bottom thing, you're always going to have x plus h minus x, or in this case, 3 plus h minus 3. It's always just going to cancel out. So you don't even really need to write that, because 3 plus 3 minus, 3 minus 3, 0. So we don't need to write that. We can just erase it. So we'll leave it as the bottom being h. So now we got to kind of do the thing that we do with all of them, and it's trying to just explode it out, you know, spread everything out. So for this case, we're going to just factor everything out. So, not factor it. How do you say, like, just desimplify it, you know? We're gonna write it out in the big form. I don't even know the vocabulary, but you'll see. So we got 3 plus h squared. That's gonna be negative h squared plus 6h plus 9. We got over here plus, we can spread out this 4 into here and here. So this turns into 12 plus 4h. And then just minus 3. Then this is all over h. Then we can also distribute that negative. So it's negative h squared minus 6h minus 9 plus 12 plus 4h minus 3 all over h. And now that you got everything spread out, you multiplied 3 plus h times 3 plus h because it's squared, which gives you this. Now you have everything nice and spread out. And from here is when you got to start canceling stuff. So the first thing we can look at are the numbers with no h attached to them. So negative 9, 12, and negative 3. And you can see negative 9 plus negative 3 is negative 12. And we have a positive 12 here. So positive 12 and negative 12, they all cancel out. So we can just cross out all of these. Now we got h squared minus 6h plus 4h. So we can combine terms, negative 6h and 4h. So this turns into x negative h squared minus 2h over h. Let me move this up a bit. And now that we're here, we can just start canceling stuff out because we got an h in both the terms and on the bottom. And you can't start canceling out h over here because there's terms in the function that don't have an h in it. So like minus 9 or like minus 3 plus 12. If those are in the function still, then you can't cancel out. And if you are going to cancel, because if you cancel out, it has to be with every single term, if that makes sense. All right. So if they're multiplied together, you only need to do it once. Like for example, if it was just like this and it was like h times 3 plus h, then you could cancel out the h from the bottom from there. So yeah. So but since we have h in all the top terms and on the bottom, we can just cross them out. So this turns into negative h minus 2. Now, that's about as simplified as it gets. So we can now bring that limit of h approaches 0 over here to the bottom. So the lim as h approaches 0 of negative h minus 2. So we're basically putting in 0 for h. So that's going to be negative 0 minus 2, which is equal to negative 2. And then that is our answer. That's going to be the instantaneous rate of change f3 at this function. Instantaneous rate of change at 3 for this function. And yeah, it's a pretty tedious process, but you know, eventually you get through it, and maybe you go to the next unit, and eventually you graduate, and then you don't have to do this stuff anymore. But for now, we're gonna push through it. All right. So now this way is just slightly harder. We're gonna find the instantaneous rate of change expressed at each point in the function. So I'm not sure how exactly they're gonna write out the question. It's gonna be something along the lines of this. I kind of just like freestyle this off of my head, off the dome. So it's gonna say something along these lines. All right, and then from there, you gotta do the same process. So yeah, let's do it. So what's gonna be very different about this one from the number one is, hold on, let me adjust this camera real quick. All right, hold up. Sorry, technical difficulties. All right, here we go. All right, so what's gonna be different about this from the number one is instead of using a number, you're just gonna write out the function. So let me show you. So we got f of x is equal to negative t squared plus 4t. We're going to write down our points, x and f of x, x plus h, I meant, and f of x plus h. So now, all we got to do, we got to plug in the function. So it's going to be for the f of x. So it's going to be x, and I'm just going to change these t's to x's, if that's all right with everyone. So negative x squared plus 4x. So we got negative x and x and negative x squared plus 4x, x plus h, and negative x plus h squared plus 4 times x plus h. Oh man, this process is so tedious. It's making me stumble over my own words. So that just goes to show it's even challenging for me. And I've taken this class already, and I've taken the classes above this class already. So if you're struggling with it, it's no problem. But good thing you're watching this video. You're practicing. You're gonna get it down. You're gonna nail the next test. And yeah, you got this. So anyways, let's continue. So let's put it into our function. Hopefully you memorize this. So limit as h approaches 0, we got f of x plus h, which is negative x plus h squared plus 4 over x plus h. Oh man. And then minus negative x squared plus 4x all over h. Oh man, it's tiring doing this. So now we gotta kind of blow it up, unsimplify everything, and spread everything out. I still don't know what it's called, but you guys know what I mean by now. So negative h squared minus xh minus h squared, which is the spread out version of x plus h squared. It's just x plus h times x plus h, and then I moved the negative, or I applied the negative to all of them because then there's a negative in front. Plus 4x plus 4h minus and then we can spread out the minus through these ones, so it's plus x squared minus 4x. That's a disgusting looking function right there, I'll tell you what. So now it's time to start canceling. So I see a negative x squared and a positive x squared. Cancel those out. I don't see a xh anywhere. We got a minus 4x and a plus 4x here. And missing anything? We're missing anything? Can you guys let me know? Talk to the screen. Let me know if I'm missing anything. I don't think I'm missing anything. So we got negative xh minus h squared plus 4h over h. Now we have an h in every term, so we can start canceling again. So let's do it. Boom, 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 boom. So this turns into negative x minus h plus 4, I believe. Let me double check if I'm writing this right. Okay, I just noticed something. When we distributed this, we forgot to add a 2 right here because it should produce 2 xh's. So there's a h and x, and then there's, because it's like h times x, and then there's the other x, and then times the h. I didn't explain it very well there, but there should be 2. So basically, whenever you're squaring an x plus h squared, there should be 2 xh's. So just write a 2 in front of there. So it's just a little mistake that we can just correct real fast. Just add a 2. So we should end up with 2x minus h plus 4. Now that's about as simplified as it gets. So we can bring back down the limit as h approaches 0. We don't need to put it equals there. And then, so yeah, we're just turning this h into 0. So this is equal to negative 2x plus 4. So that is our derivative, or function that shows us all the instantaneous rates of change of a function. So if we go back here, let's say, so we had 3, negative 2. We plug in 3 right here. So we say negative 2 times 3 plus 4. That is going to be negative 6 plus 4, which is equal to negative 2. So, let me move this up. Negative 2. So, yeah, we got it right. And, yeah. So that's how you do it. Next up, we're finding it for a rational function, which is the newest thing that we've learned in Mr. Hall's class, and it's very difficult. So, let me show you how to do it. So let's begin by just doing the same thing we did last time. So we got x and 1 over x plus 1. We got x plus h and 1 over x plus h plus 1. Yeah. So those are our points. Let's plug it into our function. So lim as h approaches 0 of 1 over x plus h plus 1 minus 1 over x plus 1 over h. Now from here, there's 2 different ways that you can solve it. There's Mr. Hall's way, and then there's my way that I like to use a little more. Both ways work, but both ways work. You can just choose whichever one. There's no really difference to them. So one of them is, so basically what you're trying to do is you're trying to clear these fractions. So what Mr. Hall likes to do is he likes to multiply them, get them to so they have an equal denominator. So for example, you multiply x plus h plus 1 over x plus h plus 1 here, and then x plus 1 over x plus 1 here, and then that will give you equal denominators, and then they could go together, and then they combine, and then from there you can start simplifying things. What I like to do is I like to clear the functions by also multiplying them to the bottom. So for example, we multiply one thing at a time to clear these denominators, if that makes sense. You guys will see. So let's say we'll start off with clearing this denominator, x plus h plus 1. And I'm going to multiply both sides by this, top and bottom, because this simplifies out to 1. And if you're multiplying a function by 1, it doesn't change it. So over here, if you multiply it to both of these, it's going to cancel here, and then you just got to kind of add everything in. So this turns into 1 minus x plus h plus 1 over x plus 1 over h times x plus h plus 1. Alright, so now you got to clear the other denominator, which is x plus 1. So you're going to do the same thing. Multiply by x plus 1 over x plus 1. Those are going to cancel out. So you're going to end up with x plus 1 minus x plus h plus 1 over h times x plus h plus 1 plus 1 times x plus 1. Whew, man, that's all. It's tiring just writing this out. So next thing you're gonna do is just start canceling out like you did before. To make this easier, we can like spread out this little top term here. So negative goes into here, so it'll be minus x minus h minus 1. So these 1s are going to cancel out. We got an x and a minus x, so those will cancel out as well. So now we got negative h. So negative h, oh, I need to go down. Negative h over h times x plus h plus 1 x plus 1. So now we can just cross those out. So it's negative 1 over x plus h plus 1 times x plus 1. Those cancel out. And the reason we can cancel it out is because the h is being multiplied to everything. So the h is connected with everything. Like I said earlier, if it's being multiplied together, you can cancel out. But if you're adding it, if, for example, if this was h plus x plus 1, then you wouldn't be able to cross it out and simplify it like that. But yeah, now we got it simplified pretty far, about as far as we can, I think. Now we can apply the limit as h approaches 0. So this h turns into 0. So this is just going to turn into negative 1 over x plus 0, which is x plus 0, which is just x plus 1 times x plus 1, which is negative 1 over x plus 1 squared. And then, yeah, that's our final answer. Negative 1 over x plus 1 squared. It's very small. So I'll write it out over here. Negative 1 over x plus 1 squared. So yeah, that's the function you can use to find the instantaneous rate of change at any point for this function. And yeah, hopefully this helped you. If you guys have any questions with the video, I know some of my explanations weren't the best. If you guys have any questions, you can message me on my Instagram at CJ or you can, I don't know, text me 520-273-4246. I'll make sure to help you out. And yeah, hopefully this helped you guys. And yeah, that's about it. Have a good one, everyone.